All right, we got to do UML models. Fair warning, you start going through this, it seems really, really dry. I'm sorry. It is dry. There's not too much, I haven't been able to find too much to spice it up, but it's just something you have to do.
It's got to be a YouTube video or something, right?
Yeah.
Someone has to make up something colorful.
Yes, someone must have made this really entertaining to watch, but I've yet to meet a programmer that likes to do object modeling, just like I've yet to meet a programmer that really, really loves testing. Or do any of y'all like testing?
No.
All right, well then. So this goes in the same category. Luckily with object modeling, you're not going to have to do it as much as testing, but you still need to make sure you do it. Hopefully you'll recognize the value of testing. Of course, the autograder is testing your code. Have any of y'all submitted a lab and got it completely right the first time?
Yeah, the one that didn't have any test cases.
Oh, the one that did, besides that one. The one that did besides the one with no test case.
One.
Oh.
One? Nice. Which one? I'm curious.
It was the second one.
Oh, good job. All right. Impressive. But as you can see, that was just one of the 4 labs so far, and yeah, of all the students. So hopefully you recognize the need for testing. Object modeling, the need is also there, but it's not going to be as obvious in this class. It's hard for me to show you why it's so needed, but it is when you get into a group of people. So what do we use? We use UML class diagrams to do modeling. I've touched base on this a little, but we're going to go delve into it a little more. As I like to call it, I being the author of the book, object modeling. Okay, what's UML? Just a way to graphically represent and manipulate an object-oriented software system. Yep, we're going to use a diagram. You're actually free to use whatever diagram tool you want. I use Dia because it's free and it's what I learned. But you can use Visio or Star UML as a popular one. And I may switch to that if people keep using it. So the structure of a class diagram, what do we got? Class names up top, aka cabby. Then you have a solid line, and underneath it are its member variables. So the cabby has a company name, which is a string, and the name, which is also a string. So those are its data member variables, or its attributes. Then comes another line, and comes your methods. So it has the cabby constructor, the set name function, get name function, give directions, and then turn right, turn left, and get company. Bless you. The minus sign means those functions are private. The plus signs mean they are public.
And nothing means it's not specified.
Nothing means you didn't specify it, which means whoever wrote this was bad, because the company name and name should be private. Cabby, set name, give directions should probably be public. And also, they didn't specify what parameters are to each function. I would assume set name would be passed a name.
So the constructor is void.
Technically, it's void. It's technically void when you're modeling, even though it doesn't actually return in Java, because it actually returns a pointer, and we didn't want to mess with that. All right, attributes. Attributes are not thought of as having signatures, as do methods. However, attribute has a type. So you basically have company name string. Hey, look, they put their minus signs this time. Or maybe that's just because it was part of the slides. Methods. The name method. Wow, these are really broken down. But anyways, plus, they're all public. Cabby, open close parentheses, give directions, open close parentheses, void. So I don't know what it's giving directions to. Get company name, open close parentheses, returns a string. Notice the return type is on the right-hand side, which is different than what you do in Java. Plus signs are for public, minus signs for private. All right, good. Inheritance. All right. Now UML is going to start getting well. This part's not too frustrating. So what comes next? So what do you think the inheritance tree is here? Dog is the parent. Retriever is the child. Oh, let's just do it slowly. It's like the William Shatner way. Inheritance is represented in UML by a line with an arrowhead pointing in the direction of the parent or superclass. Wow. Or superclass. All right. That was great. All right, interfaces. Which one of those? Oh, which one of those is the interface? Oh, it's the one labeled interface. Okay.
Yeah.
It's a dash line with an arrowhead indicates an interface. Notice up there we have interface nameable. So if something's nameable, it has a get name and set name. And then it inherits from mammal, aka dog. Ooh, and then we have the solid line, which is an association, meaning that dog uses head. That is not a very good example.
Uses what?
Uses head.
Oh, why would-
I'm going to let that one be. We'll get back to that later. That is not a good example. All right, aggregations and associations. So beforehand, you had the parent class on top and the child class on bottom. An aggregation is represented by a line with a diamond. So what do you think the aggregation is here?
Steering wheel's part of the car.
Steering wheel is part of a car. That's a good way to do it. Or car has a steering wheel.
That's what
Associations are represented with no shape on either end. Okay, here we go. And cardinality, we'll go ahead and talk about this a little. But let's see, what can you tell me about, just from this diagram? I'm going to go all the way to the back of the class. Oh yeah, you can still see it from back here.
So you said, I can't read, you know.
So
Oh, you can't read it?
spouse,
No.
employee,
Mine's supposed to be-
child are
My guys are still, what's that?
child, spouse, and employee are person.
They is a person, right? Spouse is a person, employee is a person, child is a person. Let's look at the person object. Well, actually, is a person an object or an interface?
Person's an interface.
Doesn't say interface, so it's an object.
It's an actual object. It's an actual class. Also, the giveaway is there's no dotted line. It's a solid line, which means it's inheriting from a class. So what does person have?
Nothing. Technically, they have a division in job
Get
description
name,
if they're employees.
Get SSN, get age.
Oh, get age. All right, so it has those methods. And up top, what are its attributes?
2 strings and an integer.
Right, a name, was that social security
Yep.
Yes.
number?
And age.
And an age, all right. All right, so you have a person, spouse is a person, employee is a person, and child is a person. Okay, so what the aggregations mean is what's the relationship, let's see, from one to another. So here we're saying that an employee can have 0 or 1 spouse.
True.
Right,
That's something.
what's that?
Well, I mean, Mormons have multiple spouses.
But they can. They can have. They
So we're in
can
South Carolina.
have-
Legally. Put legally.
Yeah.
Legally, we're in South Carolina, and we're gonna go ahead and keep it, they can only have 1 spouse. And then what about the children, what's that saying?
0 to n.
Yeah, so they can have 0 or n children. Notice that's an association.
Now we're in China.
Now we're in China. I thought in China you're supposed to have 0 or 1 for a long time. They finally let that go, didn't
It
they?
looks like you can have 2 gigs.
Yeah, you can have 2, yeah.
Good, but Lord helps if you have a third.
Yeah, careful.
That's all.
Yeah.
You just owe them a lot of money.
You're gonna have to pick one of the 3.
You owe them a lot of
You
money.
owe them money if you have triplets.
Oh Jesus.
Wow.
We gotta go to Canada for
That's
free
why a lot of
healthcare.
people have kids in secret.
So notice what side those 0 to 1 and 0 to n are. And that's how the association is. So employee has 0 to n children. It's not that children have 0 to n employees. Which would
Dr.
be cool.
Dr.
but-
Baby.
Might as well be parents.
Might as well be parents. All right, so let's look at those last two. What's the relationship from employee to division?
Employees have a position and have a job description.
Employees have one division, or a division can have one employee.
Yeah, the way it's written is division can have one employee, which kind of looks funny. Huh. All right, how about job description?
Employee can have more than one job descriptions.
Right, but it has to have at least one. So the division has one employee. That's it.
It's a small division.
It's a very small division. All right. Cardinality pertains to the range of objects that correspond to the class. All right, wow, that was it. Wait, that was it?
That's all we need.
All right. Okay. Let's go have fun with this. So there are many different programs you can use to create these diagrams. I'm going to show Dia.
I have an idea.
Yes. Oh, that would be the Mac version. All right. If you load up Idea, by the way, it's free to download and works on Mac, Windows, and Linux, so that's why I use it. Star UML is looking pretty promising, so you could try that one as well. Go from a sort, you click over here, sorted, you have UML, and you literally can just pick what you want. Like here's a class, boom, it's class. You double click on it, you can give it a class name and start editing. What do you want this class name to be? Anyone? Sandwich?
Yeah.
All right, sandwich. Sandwich. All right. What are going to be the attributes of the sandwich?
It's gonna be
Bread type.
Yeah.
All right. Bread type.
Sandwich with meat.
What type will it be? Is it integer? Double?
String.
That's a string.
String? All right, string. What should its visibility be? Private?
Public. Yeah. So everybody should be able to change the bread type.
Now let's keep the bread type private.
Alright, fair.
What else will it have?
Meat.
Neat.
And cheese. Yeah, can't forget cheese now.
Is it only going to have one meat or could it have multiple meats?
Yeah, well,
All right, so we'll have to do meats. So we'll have to make it a list of meats. All right.
yes.
List of meat.
The list of meats.
We'll make that private as well. And what else do we need?
Cheese.
Cheese. All right. One cheese or multiple cheeses?
As many
One
cheeses.
cheese.
All right, one cheese.
Get out of hand.
String.
Look out.
All right, we'll keep it private.
Budget somewhere.
All right, is that all we want?
So Jimmy Jam.
Yep.
Should we get vegetables or?
Are we gonna have vegetables on our sandwich? No. All right.
Lettuce, tomatoes?
Lettuce.
What about condiments? You gotta get condiments.
Salt and pepper? What the heck?
All right, we just have meat and cheese. Got it.
I'm getting out of this place.
All we need.
All right, so if I were to click OK right now, sandwich has bread, meat, a list of meat, and cheese. We probably need to make the meat class since we have a list of those. So the class will be of meat. Ooh, I typed that in the wrong place. Meat. What will be its attributes? Ooh, new.
Pastrami.
Oh no, that's its. So it needs to have a type, right?
Yeah.
So it's a type of pastrami. It's a
String. Anything else? Amount?
Yeah, I'm out.
All right. We'll make it an int.
So why
Alright.
do you put the M in front of it? I already asked you, but I don't remember why.
I put the m in front of it so when you're coding, if my variable starts with an m, you instantly recognize it as part of the class. If my variable does not start with a lowercase m,
It's specific to.
it's specific to the function.
Alright.
It's just a coding convention that makes it easier for me to read. All right, so now we need to have some type of association. Let's see, which one do we want? What's this thing? Fork union. No, we don't want that. All right, so we can just drag from this guy over here. And why is there an arrow?
But
All right, we don't want that. Delete that. We want, so this guy? That's implements. Aggregation. No, we don't want aggregation. Generalization. That's interface. What's this thing? Dependency. No, it's not a dependency. Although it is actually a dependency. What this? Message?
it does depend on the type of
All right, we'll just do this. Whoop. Well, that's weird. Huh. Haven't seen that one before. All right, delete that.
Let's not mess with that.
Yeah, we're not going to mess with that today. All right, well, it has an arrow. Why do you have an arrow?
So it doesn't need to have an arrow, it just needs to have a line between.
Yeah, so we're going to use
Well,
this
there,
one.
I think you have an option for just having it as a bar. I think, isn't that
Oh,
what it
yeah,
is?
we need to get rid of this. Here we are. Whoa, I went to the wrong way. Then we'll go ahead and delete this thing. Go over here for a standard line. Move it over here. Now if we move meat around, it stays connected. And what's the relationship? How many meats does your sandwich can have? 0 to n or
0 to n.
0 to n? All right, so we will allow a meatless sandwich. All right. Okay, that looks good so far. Let's go back to editing the sandwich. What operations can we have on the sandwich?
Make sandwich.
Make sandwich, all right. We'll keep it a void. What are its parameters? Ooh, new parameter.
Needs break type.
All right, so string bread type. New. What else do you want? Oh, I did the wrong thing. I put string on top. String. There we go. Now we'll go over here. You said cheese?
Yeah.
All right, cheese. We'll make that an int. And then the meat. Sure. All right, we'll apply that. Whew, that was crazy. So make sandwich public. You pass in a string for its bread type, an integer for its cheese, and a meat for its meat. Wow. All right. We should probably have an eat function. Eat.
Who's gonna eat it?
I don't care. We'll just make it public and void.
Is there anybody gonna eat it?
Yeah, it just gets eaten. There we go. Yes.
Why'd you change cheese to end?
What was it beforehand? Oh, it was a string. Good catch. Let's change it back to a string.
How did you open that? Did you double click or did you right click?
I double clicked. So double click brings it up. All right. So we need some type of inheritance.
So maybe something to do with like Subway or a restaurant.
Or we could do a Dagwood. Have y'all heard of that?
No. Like a comic?
Is that what it's called?
Submarine?
No.
Yeah. Here we go.
Oh, it is that guy. Okay.
Yeah, there we go.
I know that guy.
On wheat?
Huh?
Is that on wheat?
Yeah.
Multi-grain actually.
So you just buy one for the whole family, and that's what you guys eat. Like each
See, look, you can't do that then.
What that?
You
What's
can't buy one sandwich for the whole family. Is that how it works?
pretty much?
I have too many kids for that.
You have too many kids?
Yeah,
Hmm.
too many kids.
All right, so we'll go ahead and try and make a Dagwood sandwich. Yeah, we're just gonna do that. And then where's the inheritance one? Implements. It's a solid one, right? Maybe? Yeah, there we go. So you go Dagwood. Oh, I did it backwards. There we go. And we probably want to overwrite make sandwich such that you could only have, that you would have to have at least, 10 slices of bread. 15 cheeses, 30 meats, or something. Something ridiculous. All right. Any questions? So when you have your next after your requirements comes your design, where I'll be asking for you to write these diagrams of the classes you believe you will be implementing. So yeah, if there's no questions, awesome. Okay. All right, sure, save. Okay. Oops, you. Oh. Wow, we're cruising through.